Welcome back, my dear students, for the UGC lecture series on lasers and their applications and the Swayam portal. Now, we are going to see some of the most advanced and most subtle applications of laser, particularly in remote sensing. For a long years, people were not able to understand what happens in the atmosphere, what makes the atmosphere, what are the changes in the atmosphere that changes everyday climate, everyday weather. For example, few years ago, you would have heard the announcement from the Department of Meteorology. They would say, within a week, we expect heavy rain. Then, sometimes the schools and colleges are closed. We will all go away happily, but there will be no rain, nothing. And we would take it as a meteorological holiday for us, because at those times we were not able to gauge, we were not able to measure what is happening in the remote atmosphere, like wind and dust and temperature. There are so many things. The flow of the clouds, movement of the air, and heat waves, all these things should be gauged properly, and then they should be put in a supercomputer. Only then we would be able to really predict what would be the movement, and the possibility of rain. Now things are much better. They always say the chances of precipitation, if you look at in any of Google, just go to Google and find out what is the climate, what is the weather today, then it will say temperature is so much, humidity is so much, possibility or the probability of precipitation is 80%, 20%, like that. Not only that, they could delineate every hour. Morning 8 o'clock, this will be the temperature, this will be the precipitation, humidity, then mid-noon, afternoon, night, everything is almost reliably predictable these days. For all of them, the remote sensing technology has helped it. Remote sensing technology means you measure the remote cloud and the remote particles at a distance of 20 kilometers, 30 kilometers, 100 kilometers, like that, employing different types of electromagnetic waves. One such electromagnetic wave is the light, and among them laser is a very powerful electromagnetic wave, which you have already because I have been teaching all this one. It is very directional. You can send a laser beam from earth to moon. That means it is so powerful that it is capable of reaching there, monitoring something there. We are not going to send it for such a long distance for remote sensing. Our range is sometime up to the level of 2 kilometer, 10 kilometer, 100 kilometer. We do not go beyond this one. However, there are certain occasions where we look at even beyond this 100 kilometers. For example, if you want to monitor ozone concentration, what is the technique? How do you send any kind of detector well above 100 kilometers? Those things were almost impossible for a very long time, but now employing certain types of laser, you can easily detect the concentration of ozone. Now, why we are bothered about ozone, you will come to know a little later. What is the problem of ozone? What is so called global warming? These two are two important factors which govern our ecological condition. This ecology has a very great impact in everyday life in the modern days. About 50 years ago, scientists and technologists never bothered about it. However, as we have been using variety of modern instruments like a fridge or variety of cars, we have been polluting the atmosphere. These things spread out everywhere and they go up also, they disturb the ecological balance. Because of such thing, there is certain enormous global warming and global ozone hole drilling, all these things happen. All these major ecological changes have a great impact on your life, on our life. Now, for this particular development, for this particular monitoring of remote atmosphere, ionosphere or stratosphere, for all of them, lasers have played a very important role. I repeat, we use variety of electromagnetic wave, sometimes radio wave, sometimes very high frequency radio wave, sometimes we use lasers. Lasers is not the only tool, there are so many other tools, but laser has provided an extraordinarily versatile tool for remote sensing. How and why, you will see immediately. Here is something I want to tell you. When we send a laser beam, it is going to fall on the atmosphere. What do we have in the atmosphere? Many possibilities are there. First thing, it will have particulate matters like a dust from the sand or from the smoke from a factory. You will have carbon particles, pure carbon particles of the size of 1 or 2 millimeter. This is something what you see in your lamp, the olden days lamp. You must have heard about chimney lamp, or if you just light a candle, you will see the flame coming up. On the top of it, you will see the soot. If you look at the soot carefully, you will see tiny particle of half millimeter, or they are all visible. They are all particles of the size of 100, millimeter, 1/10th, 10th of a millimeter or 100th of a millimeter, or sometime millimeter. That is the size. We are going to see applications of laser in remote sensing technology. As I have been telling you, in the atmosphere there are so many constituent particles. Dust, for example, dust, smoke, and very fine particles of water, and there are so many gas particles. For example, you have 80% of nitrogen gas, about 18% of oxygen, and there are so many other minor gases, particularly carbon dioxide, occasionally a little of carbon monoxide, and there are so many small quantities of many other molecules. Now, if you out of them, before the industrial situation, industrial revolution, we were having only nitrogen and oxygen and water molecule. These were the three constituents in the atmosphere. After this industrial revolution, not only the dust, not only the sand particle, not only the smokes, but people started having nitrous oxide and sulfur oxide, because they are all just manufactured in a big industry and they are all set out in a big tall smoke towers. You must have seen, particularly in an industrial area, you will see very tall towers. From there smoke keeps on spewing out. That contains all a variety of chemicals also. If the chemicals levels are very high, for example, NO2 and SO2, they can easily mix with water in the moisture, and imagine that in the gas, these gases are floating around here and there, and there is a rain, then NO2 plus water will become nitric oxide, SO2 plus water will become sulfurous or sulfuric acid. Imagine these acids are falling down on the earth along with the normal pure water. Then the plants and animals will suffer. They will all get mixed up with the water, and this will lead to variety of disease also. All these put together tells you that you should be able to quantify the pollutants, quantify the unwanted things in the atmosphere, and then you should find out how to remove them or at least reduce them. There are 3 steps in fact. You must be able to identify what are the pollutants, what is the quantity of the pollutants, and then how to get rid of them or at least cut off the percentage of them. All the 3's have to be done. So, if you have, if from the smoke, from the slide I have shown you, you have cloud, smoke, pollutants, aerosols. Aerosols means it is a kind of a mix of air with water and acids, etc. It is a combination of this one. This will be a bit thicker than what you see in the fog. I can give an example. Sometime if you are walking, particularly India, if you are walking in the winter, if you just blow air, you will see a kind of smoke coming out. This is because outside temperature is very low, inside your body temperature is about 37 degree. When you blow out, the water molecules that come out immediately condense, then you will see tiny particle that is called something like a very similar to aerosol. Such a thing you would have come across in driving car also. Suppose outside temperature is very hot, inside is very cold, then what would happen is, inside is cold means in the inside also you have some water vapor, outside it is very hot. So, you will see a thin cloud forming, water droplets forming in your car, that is again an aerosol. All these things are constituents or pollutants of the atmosphere. We are going to make use of lasers for detecting them, quantifying them. How we do that? The idea is this one. Just send a laser beam. If the laser beam goes and comes back with the same intensity. How do you do this one? You take a high power laser, put a proper series of lenses, focus it at certain point and then make it as a parallel wavefront by beam shaping technology. Then you will see a parallel wavefront going for a distance of 10 kilometer, for example. At that 10 kilometer, in fact, you must remember our clouds, the rain bearing clouds are within the 1 kilometer, not beyond them. So, 10 kilometer you can see some of the top level of clouds. So, that is the region 1 kilometer, sub kilometer to 1 kilometer is where you will see aerosol water molecules, mostly clouds. You want to look at them, then you send the laser beam. If the laser beam goes, get scattered from there, collect big lens, collect the light. If you collect the light, from the intensity difference between the light that is sent out and the light that has come back, and you know the distance, you can easily know the distance because you can send in side by side a laser pulse to go and come back. This already we have seen, measuring a distance. You can measure the distance, and not only that, you can find out what are the constituents, and third, you must find out what is the concentration, what are they. To do that, if the atmosphere contains only dust particle, only sand particle or only smoke particles or particles of size about the nature of 1 millimeter, whatever be the kind of laser you send it, it will just scatter away random reflection, the scattering. Then what you were able to capture is a highly reduced intensity. then you have to do certain mathematical modeling, and then you would be able to say that at this distance you have dust particle of this kind of size, and this is the concentration of dust or aerosol or water molecule at this height. Here remember, there is no change in the wavelength. You are able to see, you are able to get back the same laser wavelength. Only thing is the intensity got reduced because of scattering. You have to do a lot of calibration, mathematical modeling. Eventually, you will be able to find out at what distance, what is the concentration of aerosol or water molecule or the droplets concentration. All this you can do. This is the first thing. Here, what has happened is you have employed the basic of light scattering. Light scattering, and this is called maze scattering. The scattering particles are much bigger than the size of the wavelength of light. Under this condition, you will have a random reflection, but it is just scattering. That is the first step. Second step is called Rayleigh scattering. Rayleigh scattering is the phenomenon where the particle size are approximately the size of wavelength, comparable, 2 times, 3 times greater or 1 or 2 times lesser. This is the range of Rayleigh scattering. The property of Rayleigh scattering is it will scatter more light of blue than the red wavelength. So, this particular kind of scattering is capable of preferentially scattering a particular wavelength more than other. There is certain preference, there is certain that is certain way of discriminating a particular wavelength. That is the reason why the sky looks blue. This is the starting point of theory of Rayleigh scattering, and that is where Sir C.V. Raman started his research. Sir C.V. Raman went on to the next step of molecular scattering, where there is a change in the wavelength. Before we go to that one, let me get back to this one. Let us focus our attention only on Rayleigh scattering. Rayleigh scattering, imagine that I send the laser beam like this. This is the particle. The particle sends the lights in all directions. It is a random reflection. But since the size of the particle, example is water molecule, since the size of the particle is comparable to the wavelength of laser light, it will have a preferential scattering of scattering more of blue away and less of red. This is the theory given by Rayleigh, and this explained very well why in the morning the sun looks very reddish or sometimes orange, sometimes yellow. I can explain again. If there is a rain or if there is a heavy fog, if it is a cold, or in short, if the atmosphere contains a lot of water molecule, the sunlight which is coming from the horizon, the sunlight is coming like this. Here is, let us say, Madras, then it has to travel through a long distance where there is a path of water particles. Then you have plenty of water particles, means the blue light of the sunlight gets scattered away this way and this way, this way. Because of this one, if you look at the sky straight up, it will look bluish. When it goes on the water surface, the water will look bluish also. What is left out is red or orange. These are scattered very less, and that is the reason you see in winter or in rainy season, Madras sun looks golden or sometime reddish, sometime thick blood red. All the three are possible. In fact, if you look at very carefully in the early morning, when it rises, it will be reddish. Then slowly it will become slowly it will become golden yellow color. After some time it will become pale yellow, and after some time, keep on watching, as the sun goes up, it will become more like a silver, and when it goes up you cannot see that so bright, it will be a pure white. Now, why I am saying all this, and when it goes here, the path through which the light beam penetrates is going to be only this much. When it starts here, the light has to go through a long distance. Because of this one, sun looks yellowish or red in Chennai, particularly in winter or during the rainy season. Even here in summer, it will not be so reddish or so yellowish. Now, this you must compare with what happens in Delhi. In Delhi, if you ever happens to be there in the early morning, keep watching. Even in the winter, the sun will look more like a silver, it will not be yellowish, because Delhi is a very dry place. You do not have enough moisture to scatter away the blue. So, most of the time in Delhi, the sun will look like a silver. The same sun, same time, most of the time in Chennai, the sun will look like a golden color. Remember this one, you will understand many other things also. Okay. Let us go to the next step. Whatever I have said is about Rayleigh scattering. Now, it is said that Sir C. Brahman was travelling from India to England on a ship all the way, and all the way he was thinking about Rayleigh scattering. Then he saw the sky is blue, and then he saw the sea, which is also blue. Then many people said that sea water look bluish because the sea water looks like a mirror which reflects blue sky. This is reasonably correct, but not completely correct, because he thought over it, because he said in a place where there is a closed swimming pool, when there is no sky hovering over the swimming pool, even then, even there, if you have a pure water of the depth of about 8 feet or 10 feet, just a plain pure water, it look blue. Then he said immediately that water molecule in the swimming pool, they keep on what the atmosphere was doing. So, the pool, water looks bluish because of Rayleigh scattering. So, in addition, when the same swimming pool is in a kept open condition where it will produce molecular scattering of water and also reflection of the blue sky, both are happening simultaneously. On the other hand, near the seashore where there are planktons or some kind of growth there, some kind of algae, some kind of small plants floating there, it will be slightly greenish. So, if you want to find out the constituents of sea, all that you have to do is just go up in a plane or drone in these days, just to keep on taking number of photographs using proper laser light of proper wavelength, and then it will be able to show you the complete picture of the plankton, quantity of fishes there, number of dirty, if there is some kind of oil spillage, all these things could be first photographed. That is first step. Here we employ the idea of Rayleigh scattering, then you send this is what is generally done for remote sensing of water surface. On the other hand, for remote sensing of pollutants spewed out from the factory, laser has played a very vital role. How it is done, I have shown in the next slide. At some point, at a distance of 2 or 3 kilometers away from the factory domain, you keep a high power carbon dioxide laser. then shine the carbon dioxide laser straight on the tower smoke. Just keep on, just focus it, but then the laser light that goes to the tower smoke will fall on it, get scattered. Some of them will, if we have a big telescope, high power telescope with high light gathering capacity, it will capture a small quantity of light. That light you just put it through a grating, the grating will immediately produce a diffraction, and also it is capable of discriminating, separating out the wavelength component of any composite light. In this case, what it will give is, it will give the very intense light beam which was sent from here, that is the incident light which has come back without any change in the wavelength. On the other hand, if that particular pollutant have sulfur dioxide SO2, nitrous oxide NO or NO2, then each molecule will have a shift due to Raman effect. The Raman effect is a change in the wavelength due to the coupling of vibrational energy on the incident light energy. What it means is very simply like this one. Suppose I send a laser beam of wavelength, this is a typical example of 30,000 nanometer. Then it falls on NO2. Then a particular molecular vibration get excited, then that particular NO2 will take a little bit of the light from 30,000, it will swallow 2,000 wave number. Let us put in terms of, usually in terms of wave number, 2,000 nano number. So, what is coming back from there would be 28,000 wave number plus 30,000 wave number. 30,000 wave number is the light that we sent it out. 28,000 wave number is the light that was scattered back because of the presence of NO2. Next step, very simple. If you see more and more of 28,000 wave number, that represent that particular factory is sending out more and more of NO2. The next step is very important. When such a factory is there with more than NO2 spewing out than the allowed limit, and wherein there is a rain, you will have nitric acid falling down that will immediately kill the small plant, the young plants and all will immediately die, because nitric oxide is very, very poisonous, very corrosive. If it falls on your hand, you will see the itching. All these things are possible. Then the scientists who did all this experiment will report to the government, this particular factory is sending out, or they must find some way of controlling NO2 coming out of the factory. They must do something else, but they are allowing more than what is atmospheric pollution is allowed. The control board for atmospheric pollution allows only certain percentage. They are spewing out plenty of them. When this kind of control is there, you will have a proper monitoring of our atmosphere or ecology, and this is where laser has played a very, very vital role. Thank you very much.